Okay, so following on from the last video, we're now going to add the functionality that makes our calculator work. Now so far we've just focused on the visual elements by placing an entry widget at the top and then the respective buttons below. But we now want it so that when we click on a button, it gets presented in the entry widget, and then the calculation is performed when we press the equal sign. So let's begin. So first of all, we're going to apply the same technique that we saw in the last video to display information in the entry widget. And to do this, we first of all created a variable called text_input, and we set this equal to the string var class. Now hopefully you can recall what this does, but this essentially constructs a string variable or a value holder for string variables. What we can then do is inside the entry widget instance, which we've labeled as text display, we can add another option which is known as text variable, and we can set this equal to the variable text_input. At this moment in time, it's a blank placeholder, but this is what will store the result inside the entry widget. And that completes everything we need to do for the entry widget. All we now need to focus on is what happens when we click the buttons. So the next thing I'm going to do is create a variable called operator, and I'm going to set this to an empty string. And the reason I'm doing this is because when we open up the application or we clear the output, we wouldn't expect anything to be in the entry widget. We would just expect it to be blank. And seeing as the entry widget's text variable is set equal to the text_input variable, which we know is that value placeholder for string variables, to make this blank, we would need to have the operator set to an empty string. This will become clearer shortly, and what we can now do is move on to defining the functions themselves. So what types of functions do we need to create? Well, we need to create a function that deals with the button clicks of each of the buttons respectively, including the arithmetic operators and the numbers. We need to create a function that clears the display because a user might want to carry out a new calculation. And we also want to create a function that deals with when a person clicks the equals button to display the result to the screen. So these will be the three functions that we will need to complete this application. Now hopefully you remember where we place our function definitions. The functions themselves need to be defined above from where they are being called from the respective widgets below. So underneath our variable definitions, we'll put def, and for the button click function, we'll call this btn click for button click. And in parentheses, we're going to put in a parameter called numbers. Now what can be passed into this button click function could be a number, so 1 through to 9, but it could also be the division symbol, the plus symbol, the minus symbol, the two brackets, and also the multiplication symbol. So numbers here may not be the best choice of word, but it just represents a parameter that accepts input from the functions below. What we then want to do is access the global operator in its current form. So we're going to put the keyword global, and then we're going to put the variable operator, which we know upon opening the application is an empty string. What we then want to do is concatenate to this empty string what is selected by the button click. So we put operator, then we can put plus equals, and then we can add on numbers which we know is passed in by the button click, and we will convert this to a string, if it isn't already. What we can then do is put text_input. We can then access the set method by putting .set, and inside parentheses we can then put operator. So let's just think about this for a second. If a user first of all clicks on the number 1, what will happen? Well, the operator is initially empty, 1 will then get appended to that empty string, and the text_input will be set to 1. If a user then clicks on the plus button a plus will be added to the operator, which now has 1, so we'll have 1 and then the plus symbol, and the text underscore input variable will be set to 1 plus. So that's what we'd expect to see in the entry widget. If a user then clicks on 9, we would then have 1 plus, we will then concatenate the string 9, and the text underscore input would be set to 1 plus 9, all in string form. And I want you to remember that specific detail. When we click on buttons, the operator will be shown in string form. So we need to think of a way how we can convert an expression in string form so that it calculates the respective result. But more on this shortly. Let's now go and add the button click function to the respective buttons that require it. So seeing as we're going to have a separate function for the button clear variable, we will leave this command for the time being. But button bracket 1 will require a command, and it could potentially be clicked by a user. So after where we've defined the background color of light blue, we can put a comma, we can then put the option known as command, and we can set this equal to btn click. Now I want to pause here for one moment. This is what we saw in the last video, but different values could be passed in to the parameter that we've set as numbers. So button click actually requires one positional argument. So we have to open up parentheses and stipulate what we want that positional argument to consume. So for the button bracket 1, we know that we want it to be the string open bracket. But one nuance to be aware of here is that if we use functions with parameters in which we are passing in information, we cannot place these directly after the command keyword. But we can take advantage of the lambda keyword. So what we do is after the command equals syntax, we can then put the lambda keyword followed by a colon. And what the lambda function will do in this situation is essentially pass the value, in this case an open bracket, back to the button click function. So keep this in mind because we'll need to use similar syntax for the remaining buttons. So I can now copy this command line and simply change the argument that we pass in to the button click function. So if I paste this into the variable button bracket 2, we can then change the argument to be a closed bracket. If I scroll down and paste it into button 7's variable, we can then change button click to equal an integer of 7. Now it doesn't matter that we pass in an integer here, we know that in the function itself we convert this back to a string. We can then do the same for button 8 and change the argument to 8. We can do the same for 9, change the argument to 9. We can put it in the division symbol, and we can put the button click to have a / passed in as an argument. Button 4 will have the integer 4. Button 5 will have the integer 5. Button 6 will have the integer 6. The subtraction button will have a dash as a string. Button 1 will have the integer 1. Button 2 will have the integer 2. Button 3 will have the integer 3. The multiplication button will be the asterisk syntax, so we can put an asterisk in as a string. The 0 button will have the integer 0. The dot button, so for decimal places, will have a dot passed in as a string. The equal button we are going to leave for now because this will require its own function. And the addition button we will pass in a plus symbol as a string. And this will do for the time being. So if I run our code up until now, you can now see that when we click on the buttons that we've set the button click as a command on, you can see that the entry widget contains the buttons in the display. The clear button doesn't work as of now, nor does the equals button, so let's now create the functions for these buttons. The first thing we will do is the clear display button because this is the easier of the two. So we can create a function called button clear display. We can then put parentheses and a colon. We will then access the operator, so we can put the global keyword and then put operator. We will set the operator to equal an empty string, just like it is when the program is first run, and then we will put text underscore input, and we will pass in the variable operator, which comes from the line above. We now need to associate this function with the click of the clear button. So let's scroll down to the variable button clear, and we can then set the command option to equal button clear display. Now note here that we do not pass in any parameters into this function. So we don't need to use a lambda expression in this case. So we can simply put command equals and then put the function's name without parentheses. So let's see how the clear button now operates. If I run our application again and click 7 plus 8 plus 9, you can see that the expression is being displayed in the entry widget. If I now click on the C button, you can see that what was displayed has now been removed. And what we're now presenting is an empty string, so you can't actually see anything. I can now click another expression and press clear. I can now put another expression, and if I press the equals button, nothing happens as of yet. So let's now go and tackle the final function that we need to define. But before we do, I want to introduce to you a useful function that may come in handy when trying to think of a solution for this specific problem. At the moment, we know that the display contains an expression which is a string. So for example, we could have a string which looks something like 5 plus 10 plus 3 minus 2. Now an easy way to evaluate what the result is of this expression, which is contained in a string, is to utilize a function known as eval. So if I were to assign this specific expression to a variable called total, which we'll use shortly, I can now call upon the eval function. And when I look at the documentation of the eval function, you can see that the docstring states evaluate the given source in the context of globals and locals. Okay, so let's continue reading. The source may be a string representing a Python expression or a code object as returned by compile. But here you can see that the source, i.e. the first parameter that's passed into the eval function, may be a string representing a Python expression. So what happens if I pass in the variable total into the eval function? Well, if I do this and then run the code cell, you can see that we get 16 returned. And I can change this expression to any expression that we put on the calculator, and we will get the correct result returned accordingly. So what may seem like a difficult problem is solved by utilizing a built-in function. So we can define the button equals function, so we'll put def button equals, we'll then put parentheses and a colon. We'll then access the operator which we know is storing that expression that's being generated by clicking on specific buttons. So we'll put global and then operator. Now seeing as we want to store the result, we'll create a variable called total, and we'll set this equal to a call on the eval function in which we'll pass in operator, which would contain an expression at this point. And we will then convert the result of this operation back to a string so that it can be displayed in our value holder for string variables, stored in text underscore input. So our final piece of the puzzle will be setting text underscore input dot set, and in brackets we can pass in the variable total. The last thing we need to do is associate this function when the equals button is clicked. So we can scroll down to the bottom to where we've created the equal variable, and we can then put command equals button equals. Okay, great. So this should now finally complete our entire calculator project. Let's run this code cell and see what we get back. You can see that when I drag the application across, I'm able to click on any button and the application will work as expected. So we can put 8 divided by 4, and then I can press equals, we get 2.0. I can then clear the output. In brackets, I can put 5 plus 4, and then I can multiply this by 2, and then we return 18. I can clear the output. I can press 3 plus 6 plus 7, and when I press equals, we get 16 returned as the result. So a functioning calculator that we've created from scratch. Now admittedly, we've been running this calculator from a Jupyter notebook. But usually when you play around with apps on your machine, you'd go into Windows, you'd search for calculator, and you'd click on an icon for the application to launch. So how do we go about converting our Python calculator application into an executable file? One in which we can search for on our machine, double click on it, and then it will open up. Well, this is exactly what we're going to take a look at in the next video. This has so many benefits as you can hide all the complex code that forms the application and convert it into an executable. This can then be run on anybody's machine and the application will work just how you intended it to when you developed it. This will be bonus material as it does sit outside the standard Python course, but understanding how to create an executable file which can then be run on your machine or anybody's machine really unlocks the power of development where you create applications that can be used by the masses. So I'll see you in the next video.